Hello there everyone, my name is Udit and in today's video I'll be talking about classification of data structure. So data structure is divided into two types, the primitive data structures and the non-primitive data structures. The primitive data structures are those data structures which are basic in nature, okay? These are the data types which is provided by the system itself, okay? The example of basic data structures are integers, characters, double, float. These are basic data types. Also, there is one more which is boolean, okay, which is true and false. And the second data structure type is non-primitive. Non-primitive are those data types which are constructed or created using the primitive data types, okay. The non-primitive data type itself is of two types, the linear non-primitive data types and the non-linear non-primitive data types. The linear data types and non-linear data types, the difference between them is that in linear there is sequential arrangement, okay, and there is a kind of simple pattern between them. The linkage between the two data type is very simple. There is a simple linkage between them, whereas in non-linear there is various link to a particular data type, okay. Like for example, I can tell you, if I'm considering like this kind of linkage, the data type, suppose there is something called as A which is linked with B, then here you can call it as it's a linear relationship. Whereas in non-linear data types we have somewhat complex arrangement, okay. There is a complex arrangement between them. I'm just drawing an example so that I can show you. This kind of relationship exists between them, okay. Now this, what I've shown you, this is nothing but it's a linked list, and this is a tree and this is a graph, okay. So these are the example which I'm going to discuss even further. The linear data type are of two types, the static data types and the dynamic. The static are the ones which are the data types of which the memory is allocated during compile time, okay. During the compilation process, whenever the memory is allocated for a data type, then it is called as static linear non-primitive data type, okay. Then example of such kind of data type is array, okay. Array is one of the example and it's very simple. We have this kind of data implementation, okay. And coming to the dynamic data types, the dynamic data types are the ones in which the memory is allocated during the runtime, okay. Example of dynamic linear data structure is linked list, stacks and queues, okay. We will be understanding each of them briefly in upcoming modules, but right now just you take an example. It's an example of dynamic in which the memory is allocated for the data during the runtime, okay. We don't need to declare that yeah, it's going to store so many values. Like this is one of the disadvantages of array which we have learned in our previous classes, is that if I'm having array, let's say the name of array is let's take char, that's most used. So if we have name called carry name ar, which is of size 10, for example. Now if someone in this data type, if someone enters ram, okay, then here you can see 3 blocks of memory is only used and the rest remaining 7 remain unused. So that's a wastage of memory. So this is one of the disadvantages of static memory allocation. This disadvantage is overcome in dynamic. In dynamic, whenever you need something, you need the memory is allocated, okay. So using dynamic we can save a lot of memory space, and in most modern programming we use dynamic data types, okay. Now coming to the non-linear data types are the ones which have somewhat complex arrangement, like I've shown you here. And it is of two types, the trees and graph. Sorry, the example are two, the trees and graphs. The tree is somewhat like this and the graph is somewhat like this, okay. Now the trees are also of two types, here the binary trees and the multi-way search trees. The graph is also various type. We'll be covering each of this data type briefly in upcoming modules. Okay, now since we know the classification of data structure, let us move to the next part, which is abstract data type. Okay, now so let us understand what is abstract data type. Now to understand this term, I'm going to divide this term into two parts. The first is data type and the second is abstract, and then I'm going to combine both of them and tell you the definition. The data type is nothing but a set of values a variable can take. Okay, like for example, if I have a data type called as integer a, which is 10. Now this a can hold value 10. Okay, so this variable can hold value 10 of type, which is of type integer. If I have float a equals to 20.001, like something like this kind of thing, then this is going to occupy float type data into this variable named a. Now to understand abstract in context of data structure, we need to first understand that to solve any problem, like in general, we have to follow two approach. The first approach, we make an idea of how we are going to solve a problem, and the second is how we are going to apply it. Okay, the first approach is called as generally as logical or mathematical or abstract view, whereas the when you are applying those things, then that is called as implementation view. I will give you an example of it, like this example. Now suppose this is a laptop. Okay, now this laptop in abstract view, I can consider that I'm going to purchase a laptop which is having a 15-inch display. It has 8 gigs of RAM, it has 4 GB of graphics, it has i7 processor, 8th generation, it has a Wi-Fi 4.1 technology, and so many features. Like this is kind which I want in my device. The device is not ready, I'm just imagining such kind of thing. Okay, now in implementation view, I'm actually creating my imagination or my logical or my mathematical or the abstract view. I'm creating it. So I'm implementing is using structure. Okay, because since we are studying data structure using C throughout the series, so we are using structure. So here I have something called a structure named laptop, and this is going to have a char pointer name, char pointer processor. We have integer RAM, which is going to hold integer type data type. We have int graphics, we have char pointer Wi-Fi, which is going to basically, I'm just implementing it. The reason behind having two type of view is that in different languages, different computer languages, the implementation is different. Okay, like for example, in C language we are using structure. Okay, in most object oriented programming languages like C++, Python or Java, we use classes. Okay, and using classes we create objects and then we do it. So since there is a different approaches there for different languages, we have these two kind of views. Now the abstract view is universal, means it's universal and it's all the programmer have to follow. And the implementation view is the view which is going to be decided according to the programmer. If I want using implement using C, I'm going to use C. If I want using C++, it's going to be different. If I'm using Python, it's going to be different. If I'm using Java, it's going to be different. Okay, now with this we come to the definition, what is abstract data type. So abstract data types are basically those data types which are abstract in nature, or you can say are those data type which have logical or mathematical view, but there is no implementation details. And the best example to abstract data types is that I'm mentioning here. For example, you can take example of stack. Now in stack we use a protocol known as LIFO. LIFO means last in first out. The element which is placed last is going to be the first which is going to be out, or you can say pop first. So we will be covering this into brief, don't worry, we'll be covering this. This is also abstract data. We know what the protocol is, but we don't know how to implement it, because that's what abstract data type is. The second example is queues. In queues, we follow FIFO, which means first in, first out. The element which is first placed is going to be the element which is going to be first out. Okay, so here we know the protocol, but we don't know how to implement it. So that's kind of what example of abstract data type is. I hope it was clear for you what is abstract data type and the classification of data structure. If you have any doubts till now, you can comment down below, or you can DM me on Instagram. My Instagram ID is at the rate Udit_Swarupa. And in the upcoming video, I'll be discussing about algorithms and the approach to algorithms. Okay, till then, thank you for watching this video.